The video of today is going to be co-edge and compensation. Can you use compensation and co-edge at the same time? Short answer, yes. Long answer, it's not that hard. You're just looking at it wrong. So the software is quite nice, and it actually is a lot more, it's a lot better put together than I originally thought when I first started using this 3 years ago. So we have a 40 millimeter square. I didn't have it 100% perfect, but we can see down here 40 millimeter length, 40 millimeters plus a little bit, so no big deal. And let's go ahead and measure in the top, and we're going to go down. And again, I try to get a straight line here, and again, just about 40 millimeter. Okay, so we're going to select the object and we're going to compensate it. And we're using this to, there's no reason you would ever have a 3 millimeter compensation. It's crazy. It would never work. We're going to go ahead and do a rectangular corner because normally, I mean, you might use this, but on a real compensation, it's so tiny you don't notice it. On this, it's going to be a lot more extreme. So let's go ahead and hit OK. And we see our compensated line. Let's measure what our compensation is. It's, of course, going to be 46 millimeters because that's what we set it for. But let's go ahead and check just to verify it for the demonstration. And 46 millimeters, 45.94. Obviously, I was just off a little bit. So it's 46 millimeter. Now let's go ahead and select this part, and we're going to send it to the part library, and we're going to send 4 of them over there. And now we're going to go ahead and nest the part in the parts library, and we're going to do automatic co-edge max number 4, and we're going to hit OK. And we see now that we have a co-edged result, and we see that our compensation is gone. Well, that's not going to work. Now wait a second though, it isn't gone. The compensation is still here. So what we're going to do is we're just going to measure to confirm this. We're going to measure from this line over to this line, and we'll see that we have 46 millimeters. Well, it's not quite, but I just missed. It's 46 millimeters. And that's the compensated size. So it is compensating it. The part is compensated. What you're seeing though is that when it does the co-edge, to simplify the image, it deletes the extra lines. So it's only showing the line that it's actually using. I have one way I can show this just a little bit better even still, and I'm going to go ahead and do that. Okay, so we have something that'll work here. 6 millimeter hole radius means it's a 12 millimeter hole, so we should see some interesting results when you do compensation. So let's go ahead and click OK on that. And we're going to take this part and we're going to make, we're not doing that, we're going to compensate it. So we're going to compensate, and we're using a 3 millimeter compensate. So we can see that white line on the inside is the compensation because it shrunk the outside for some reason. Let's see if we can figure out why it did that. Compensate, inner mold out. Okay. Apparently can't tell that that's the outside. That is outer. There we go. Okay. Sometimes, especially in the pre-populated stuff, it gets a little stupid. Okay, so we have our compensations. So let's just measure this real quick and just see how big the part is. And where's that measure? Right there. Okay, so again, we have a 12 millimeter hole. Let's do our measure again, and we're going to measure our inner hole, and it should be 6 millimeter. And right about 6 millimeter. I just missed the corner a little bit. The measure tool doesn't snap, so I'm kind of having to get it right on. Okay, so this is the green line's 20 millimeters, and then the inner line should be 14, 16, right? 14. Yep, 14. And then I believe is this a square hole? I can't remember. I screwed around with it for so long. And again, 20, so yeah, it'll be 14. Okay, and let's grab the measure tool again, and we're going to measure the outside edge of this. Okay, so it is 86 millimeters across, so it's an 80 millimeter hole. Okay, let's go ahead and send this part over into our parts library. We're going to go ahead and ask for, let's ask for 8 of them, and we're going to nest them. And we're going down and we select automatic co-edge, and we're going to click OK. And we see that they have been co-edged. And we see that our compensation is gone, or at least we think it is. So let's grab that measure tool again. And we're going to go right across, and right there's our other line. And we'll see that this is now 86 millimeters across. So what happened to our 3 millimeter compensation on each end? It's still there. The original line is right here. It's just invisible. The same thing goes for the holes. They should be 12 millimeter, but they're going to be 6. So let's zoom in on the hole, and we'll grab from right there on the grid to right there. And it is 6 millimeter. So again, it was a 12 millimeter hole, and now it is 6. So that's because there's a 3 millimeter compensation on here. Obviously, a 3 millimeter compensation isn't real. It's just an illustration. It's taking it to an extreme so we can clearly see that the compensation is still there. So when you compensate something, the inner line, the original line of your part disappears, the compensated line remains, and that is what is being co-edged. So you can co-edge parts that are fairly precise without a whole lot of risk. I was unaware of this up until someone asked me to test this, and wow, sure enough it is here. Co-edge seems to work actually pretty great. So let's go ahead and run a co-edge, and you can see why a co-edge is useful. So that part is still hanging there. Clunk, that part just dropped. The other one's dropped right now. So 2 parts are down in the tray right now. 3 parts are in the tray. 4 parts are in the tray. And we're waiting. And 5 parts are in the tray. 6 parts are in the tray. 7 parts. 8 parts. Okay, so the other thing that would be good to add to this obviously would be some micro joints or something like that to keep your parts from falling in. You can add micro joints. It's not really a big deal. I don't know if you can do it on the... I had some trouble doing it on the parts. I'm going to try it again real quick. Okay, so we have our part, and let's go ahead and try to do a micro joint. And that's one of the reasons it has problems with it is... Excuse me. So the micro joint disappears, and that's a persistent problem. The micro joint disappears off of the inner hole, so I believe you need to stick it on the outer. Let's see if that can happen. So let's do a 2 millimeter micro joint. Okay, so it's stuck it in there. And let's do one on each side just to be sure that we got it. And let's see if it accepts that. So we're going to go ahead and nest again. And let's see if there are any micro joints here. And there are not. Let's run a simulate and just see if it has them still in the simulation. There are not. So that is something to be aware of, is that micro joints don't carry through. Let's go ahead and try a different approach on this. Well, there's one approach that I am aware of you can do. So you can stop it, and on the nest result, you can click micro joint, and you can walk down and just micro joint each part. And the micro joints will hold them there. Although the purpose of this essentially is to drop the parts. I'm not sure what the grand scheme of things would be with that, how you would keep them clean. Perhaps there's a different way or a different approach. Again, not something I normally do, so worth looking into though. So let's see this again, and it's it has left the micro joint there, so that's good. Yeah, so that works. You can micro joint them like that, and if that's a time saver for you where you replicate or rather reuse the same nest result over and over again, that could be profitable to you. Otherwise, maybe this isn't the most useful way to do this, but just for clarity, the compensation does stay through co-edge.